Problem number 1 is the definite integral from x equals 1 to 2 of 1 over x squared dx. We want to rewrite this so that we can antiderive it, which means making it x to the negative 2 dx. Now we antiderive, so that becomes x to the negative 1 over negative 1, and it's going to be evaluated from x equals 1 to x equals 2. Now we don't see any negative exponents in our answers, so it's probably best to rewrite our antiderivative. X to the negative 1 can be moved down into the denominator, and the 1 doesn't matter, but the negative sign does, so we need a negative somewhere. You can have it out front, you can have it in the denominator, you can have it up in the numerator. Doesn't really matter, but you do need a negative somewhere, negative 1 over x. Again, that's being evaluated from x equals 1 to 2. We're going to plug the 2 in first, so we're going to have negative 1/2 minus, and then we plug in the 1, which is negative 1. So we have negative 1/2 plus 1, which is 1/2. Problem number 2, using u substitution, u is equal to the square root of x. Rewrite this definite integral. Okay, so we got to change 3 things: the integrand, the differential, and the bounds. Okay, so quickly looking at the bounds, we know that we have to plug the 1 and the 4 in for x. So we plug in 1, square root of 1 is 1. We plug in 4, square root of 4 is 2, so our new bounds are going to be 1 and 2. All right, that immediately eliminates A, B, and E. So our answer is either going to be C or D. Okay. So if we make u equal to the square root of x as we're directed to do so, which is the same thing as x to the 1/2 power, well, du is the derivative of x to the 1/2, which is 1/2 x to the negative 1/2 dx. All right. And that is the same thing as 1 over 2 times the square root of x. Why the square root of x in the denominator? Because our exponent is negative, so we're going to move it down into the denominator, and then the 1/2 and our exponent is the same thing as the square root. So we have 1 over 2 square root of x dx. Go back to the original, we have our dx, we have our square root of x in the denominator, we don't have the 2 in the denominator. So we need the 2 in the denominator, which means we need a 2 in the numerator out front. So we want the 2, not the half. Our answer, once again, is C. For number 3, the integral from 0 to 3 of x plus 1 to the 1/2. So what are we looking at? Antiderivative. Well, you might want to go with some u substitution here. You don't actually need it. We'll do it just over here on the side. U is equal to x plus 1, because we do technically have an inner function to a power. All right, du is equal to dx. All right, so we can see here that this is the same thing as u to the 1/2 power. All right, so we have u to the 1/2 power du. If we're going to change over to u, then we need to change our bounds. When we plug in 0, 0 plus 1 equals 1. When we plug in 3, 3 plus 1 equals 4, so we have 1 to 4. All right, now when we antiderive this, we end up with u to the 3/2 over 3/2. All right, and that's being evaluated from 1 to 4. Keep in mind that you don't actually have to use the u substitution here because the du is equal to dx. You may also still have this in terms of x, in which case you would have x plus 1 to the 3/2 over 3/2, evaluated from 0 to 3. Notice the change in the bounds. We use the 0 and the 3 for the x. We use the 1 and the 4 for the u. Both of these are going to produce the same answer. Okay. If we are dividing by 3/2, that's the same thing as multiplying by 2/3. Right, so there's our 2/3. And u to the 3/2. So if we have an item to the 3/2 power, that means that we are cubing it and taking the square root. Now that might be a little bit easier for us because we see that we have no rational exponents in any of our answers. When we plug in 4, that means we have the square root of 4 cubed. 4 times 4 times 4 is 64. When we plug in 1, we have the square root of 1. All right, so what we're looking at, the square root of 64 is 8. 8 times 2 is 16, so that's 16 over 3. Square root of 1 is 1, times 2 is 2, so that's 16/3 minus 2/3, which means our answer is 14/3. With number 4, we're told that f is a linear function. and a is less than b, and we're asked to find the second derivative, or the integral from a to b of f double prime of x dx. Okay, well this is going to be equal to the antiderivative of f double prime is f prime of x, and that's going to be evaluated from a to b. Right. So that means that we want f prime of b minus f prime of a. Right. Now we're told that f is a linear function. I'm not told exactly what it is, but it's just some linear function. So we can just, say f of x equals whatever. You can do mx plus b. You can put in some numbers. You can do 2x plus 5. It doesn't really matter what you have there, as long as you have a linear function, which means the degree is 1. Right? Well, if f of x is 2x plus 5, what's f prime of x? F prime of x would just be 2. If we wrote mx plus b here, then we would just have f prime of x would be equal to m. Okay? It doesn't really matter what happens with what you choose as your linear function. The derivative is just going to be the slope. It's just going to be a constant. So it doesn't, when we go to plug in b, we can't because there's no value there. There's no x here. It's just 2. So f prime of b would be 2, and f prime of a would also be 2, and that's equal to 0. So that's our answer, A.